Number 4 says a projectile is aimed down below the horizon at an angle of 30 degrees and it's fired with a speed of 20 meters per second. I forgot to say how tall the cliff was. Just assume the cliff is the same as the one right above it, 20 meters tall. I'm sorry, I forgot to say that. My bad. How far from the base does it land? How long is it in the air? What's the speed just before the impact? So here's my scenario. Now I'm not firing it horizontally. I'm actually aiming it down. So I'm firing it downwards with a speed of 20 meters per second. So I'm shooting it down with a speed of 20 meters per second. With an angle of 30 degrees. So I have this out here. This is 30 degrees. So the first thing I'm going to do is I'll break it down into its vertical and horizontal components. I know that this thing's 20 meters tall. So VI, VF, ATD, velocity, distance, time. Okay, so I'm going to break this into its X component and its Y component. So this is going to be 10 because it's a 30, 60, 90 triangle, and this is going to be 10 root 3. .3. So the horizontal velocity is 17.3. The vertical velocity is negative 10. You know what I might just do? I might make positive down in this problem. So instead of this being a negative 10, let's make it a positive 10. So the acceleration is going to be a positive 9.80, and the distance it travels is going to be a positive 20. That makes this problem a whole lot easier doing it like that. So let's go. So I think the first thing I'm going to find is the final velocity. I think that's the easiest one to find, so we'll go VF squared equals VI squared plus 2AD. So VF squared, VI is a 10 squared plus 2 times 9.80 times 20. And it's funny, if you use negative numbers, a negative squared is a positive, a negative times a negative is positive. So it's funny how it all works out as long as you adhere to the sign conventions. So that's 100 plus 2 times 9.8 times 20. 492. And I take the square root of that, I get 22.2. So the final velocity is 22.2 meters per second. Right there. And then I can go right into the time. VF equals VI plus AT. Final velocity, 22.2. Initial velocity, 10. Acceleration, 9.8 t. So 22.2 minus 10, 12.2, divided by 9.8 is 1.24 seconds. So 1.24 is the time. So then to find velocity equals distance over time, the velocity is 17.3, the distance unknown, the time 1.24. 21.5. 21.5 meters. Okay, so let's see if we can answer any of these. How far from the base? That's a horizontal distance, 21.5. How long is it in the air for? That's my time, 1.24 seconds. What's the speed just before the impact? Let's see. It's moving forward when it hits the ground right here. It's moving forward at at 17.3. It always moves forward at a constant velocity. So anywhere along that, it's always moving 17.3. Vertically, it's moving down at 22.2. So I use the Pythagorean theorem, a squared plus b squared equals c squared, to get my final answer. Is 28.1. So this hypotenuse is 28.1 meters per second. So what's the speed just before its impact? 28.1 meters per second.